All right, let's talk about sequencing in VCV Rack. Just be aware that this is going to be different from your DAW. By default, it doesn't have a piano roll sequencer in there, although you can download one from the VCV library. But a couple key ideas to get before we talk about this in class. Like I said, you can download a more traditional sequencer, but it's a little hard to find it because there are over 200 different types of sequencer just in the VCV free library. So feel free to experiment with these, but I'm just going to talk about Seek 3 for now. If you want to experiment with them, by all means. But there are a number of different types of sequencer. They kind of fall into general categories of pitch and gate, gate only, clock trigger gate, Euclidean sequencers, or stochastic sequencers. So we'll just talk about those really briefly. Pitch and gate is the most common type of sequencer. Usually it sequences volts per octave and a gate signal. Typically this is in a row or 2D array where you have a row of different knobs and you can turn those to set the different volts per octave, and then it will give you a row output and a gate output that are synced to a clock. So it will step through, send one value from the row, one value to the gate. Gate-only sequencers are rhythmic sequencers that only output gate signals, so hence the name. And these are typically used to sequence events, but not pitch. So they're great for triggering envelopes, for triggering one-shot sample playback, for doing A-B switching, or any type of either-or situation. Clock, gate, and trigger sequencers, which usually include clock dividers and multipliers, are very useful. They take a clock signal coming in, or a gate or trigger high signal, and they split that repeating periodic signal into either multiples or subdivisions based on how you've set them. The classic use is for drum sequences, where you subdivide an incoming regular pulse into faster pulses or into slower pulses, and then pair those up to different drum modules. It's also very useful for other timed sequences or for switching between time sequences if you have a counter attached to it. So this is where you would see modules like sequential switches come into play, and those are typically going to change what they let output after every X number of pulses they receive. Very useful. Kind of crazy to get your hands on those at first, but a little experimentation and you'll have it. Getting into the cooler stuff, though, you have Euclidean sequencers. These are a personal favorite. They're really cool, but basically the way that they work is that they take a division algorithm from Euclid's elements, and what you say you want to do is you want to divide X number of pulses across Y number of beats as evenly as possible. So if I have 13 beats and I have 7 pulses, how do I do this so I create the most uniform pattern of pulses and rests? And if you follow Euclid's algorithm, you get these patterns that are very, very, very close, or in most cases identical, to rhythmic patterns that are used all over the world in traditional music. So things like the clave, the tresillo, the cinquillo, tons and tons of different patterns that pop up in African drumming traditions, in Arabic Ika, in Indian ragas. Very, very cool stuff. They're very human sounding, though, is the most important part, which means that if you use a Euclidean sequencer, you're going to get some really interesting sounding sequences, even though you're just generating, hey, do this, so, using math. Finally, we have stochastic sequencing, which uses probability to generate rhythmic events. This is heavily influenced by Xenakis and his work. And occasionally you'll see some that have pitch as well. It's usually a little bit more common to have the pitch be a separate sequencer, but not always. One thing to be mindful of, though, is that because probability is involved, they will not be purely 100% random. you will notice small scale patterns emerging over time the longer you let it run. But for our purposes, we're going to start with Seek 3, and if you so desire, you can move beyond that. So to review, Seek 3 is built into the VCV fundamentals object. It outputs voltage, not pitch, and not rhythm. So it's essentially a multi-stage series of values. In each row of dials, you set the dials to what you want them to be, and that much voltage is output. And it goes left to right based on the number of steps, 1 to 8, while the clock controls the speed that it takes between each column. For every one of those values, it outputs a paired gate, either using the gate output up top next to the row outputs, or in the column corresponding to whichever column it's currently played on. And you can turn those columns' gate outputs on or off using the green buttons below it. If you want to use the clock control on the sequencer, then you make sure that run is turned on, and then you can use the clock dial. Otherwise, you can just connect an external clock to the external clock input, and it will work. And again, each row, the values of the 8 dials can be changed independently to give you different values, and the gates can be turned on or off for each column in order to have a rest or to not output anything at that specific point. So these are kind of the basic, most old school type of sequencer. This is very similar to the original bookless sequencer, although that one had 16 steps, I believe. You can still find these very, very commonly. Korg makes one, as does Moog in their DFAM drum machine. So they're still out there. They're still popular. This is what you're going to start with. And then if you need to go beyond that, you can always go to VCV's library and find an additional sequencer.